Okay, good afternoon. Thank you all for attending so numerously in this smallest Esaborillo hall. By the way, who is not from Malaga and would like to know what Esaborillo is, in case any previous speakers here haven't mentioned it? It's somebody who isn't funny at all, somebody who doesn't have a spirit or happiness in his life. That's an Esaborillo. Okay, let's hope we don't honor this hall with this. But first of all, yes, I have something that is sad and a little bit Esaborillo. Now, we are passing through a difficult moment geopolitically in Europe, and EPAM is a company which has had strong ties and a strong presence in Ukraine with more than 16,000 employees there and also in other CIS countries like Belarus and Russia. And we are doing a great effort setting aside a big chunk of budget for helping Ukrainian EPAM employees and their families to come to safer places. In the last months, we already have relocated more or less 130 employees to Spain and many, many more to other European countries where EPAM has a presence, and we expect to keep up this pace in upcoming months. And we are also relocating people from the other countries in the area who feel insecure and who want to leave and get out of all this trouble. And we always put our people first and take care of each and every one of them. Now, compulsory shameless bragging slide, forget about it. Okay, EPAM started its journey here in Malaga almost 4 years ago. And we all met the last time 3 years ago on Jay on the Beach 2019. And EPAM and my colleague Vlad Vorobiev, who's sitting there, we were able to prepare, and he delivered a quick lightning talk on basically the evolution of software deployment. And then we took a look at Spinnaker and Packer and how we handled entire virtual machines as deliverable artifacts. But today, we're going to start with a little bit of history. Nobody really was able to foresee this when in 2009, 2006, Amazon launched its first two services in the cloud. Yes, we didn't expect it would change the shape of IT as we knew it. Those two services were S3 and EC2. So basically, you had a place to put your data, and you had a place, all the resources for processing it in place. This was nothing new, right? You could rent servers in the cloud, rent a data center, rent colocation, but what you couldn't do before is actually provision, spin up a server with a couple of clicks on an interface or with a command line. And once you no longer needed that space and you no longer needed that processing power, you could just do away it. Build by the minute, zero infrastructure, or your infrastructure in a completely dynamically way. Nobody was taking it serious. They said, this is not for us. Yeah, how wrong they were. That's only one part of what makes the cloud. Because just 4 years before that, the first State of DevOps report was published. So agile software development did teach us how to develop software and deliver it in faster and more efficient ways. So, and this is a little bit of the issue. So business developers, operations, they all laid their hands on different parts of DevOps. And this is why finding a definition of DevOps nowadays is really still so difficult. Yes, because depending on what angle you look at it, you get a completely different perception. Yeah, so what happened? Cloud services, with their elasticity, with their availability and flexibility, they took DevOps and agility also to operations. Another thing that helped us a lot was Docker. So none of these things would be as convenient, as practical as containers for managing dependencies. We had virtualization, we have CH root jails, we have using different ports, separate user services daemons to make several pieces of software coexist on one server. Docker would immediately take out the guesswork out of this, because one application could use a specific version of a specific software or library, and this would be almost impossible to manage on a single machine. With Docker, we were just able to embed these dependencies into our container and run them anywhere. There's a particular case that I encountered at the very beginning of using Docker when I was in a telco company, which was the implementation of an SMSC, of an SMS server. And they insisted on a particular Linux distribution. I don't remember exactly which one. But then the software was written in Perl. So we had to install modules from cpan manually that were not part of the operating system distribution repositories. It was a nightmare. Every time we had to set one up, it took 2-3 days of manual work, because at the time also Ansible or Puppet were not able to automate the installation and downloading of Perl modules from cpan. So in the end, I discovered Docker. I wrote a Docker file, which took me about a day or a day and a half. And from that moment on, provisioning SMS servers was a matter of minutes. Intermission, meet the pilot. There's another big player there, which is Kubernetes. This would simplify things enormously. Yes, because containers running on a single Docker machine are not too good in terms of scalability and reliability. So we could join several machines with container runtimes on them together into a cluster, and our fearless pilot, Kubernetes, would take care of guiding them all safely to the port. Finally, now we know who we're meeting. New approach on software development, way to easily deliver software packaged as a single artifact, way to elastically provide hardware resources, and a convenient way to run software at scale. So what happens to our software and to our system? We don't need to treat them like pets anymore. Now we can treat them like cattle in a farm or like a herd of sheep. And this is really the scale we want to achieve and the easiness and comfort we want to achieve when moving things to the cloud. Okay. So when we used to treat software as a pet, we had to be extremely careful, yes? So 2 pets in a home have to be compatible. This picture of the cat and dog getting along well, we know it's not always the reality. Yes, even then, each needs its own space, its own bed, its own place to sleep. Yeah, we normally have to feed them separately. The vet told me, don't give a dog cat food because it has too many proteins. So yes, we need to take care of them separately. We have to scoop up their droppings and clean the litter, and we'll come to that later. What would you say is sort of the waste product of an application? It's the logs, yes. When we were maintaining software on a machine, on a virtual machine or on a physical server, we used to have to take care of the logs manually. I mean, who hasn't been for several years and hasn't found var log file system has filled up and your server stops working? They need individual care and playtime. And if they get ill, we need to take care of them immediately so that the illness doesn't get worse. Take care of them, and in the worst case, take them to the vet. If they get very, very ill, unfortunately, we have to get rid of them. And this is a very, very sad moment, which causes big impact on us. Now, we have started industrializing this and treating software and treating our systems not as pets, but as cattle. They comfortably live in a stable, a big place, made to house several of them at the same time. Yes, so many can share the same space. Feeding them is done in bulk from a large silo, no manual intervention. Waste falls through a grid in the floor and is automatically removed. And if one gets ill, what we do is, of course, we take care of it. But first of all, the first thing we do is we isolate it from the rest of the herd so that we don't get the other animals sick. Finally, if one perishes, yes, it's still sad, but it doesn't really matter because there's still plenty of them. So they continue to be there, serving their purpose, and continue producing. As we said earlier, you can fully automate cloud providers. So in the same way where we have started treating our software as cattle, as a commodity, we can always also start treating our infrastructure as a commodity. Yeah? Think of AWS or of Azure as the land that you sort of own or that you can rent, and that you can rent different plots there, or that you can raise new fences in order to create a new area for your cows or for your sheep to pasture on. Number 3, communication in the farm. Okay, we need to find a way for our software to communicate. And there is something that is essential in the development process and in the design process, which is what we call the API-first approach. We need to abstract the way software communicates with each other from the code, from the actual implementation. What's that mean? Design an API from the beginning, design it on paper, and then if somehow possible, never ever change it again. So apply a principle of strict immutability to APIs in order to always preserve interoperability. There is another thing, handling persistence. That is a separate functionality from the application as well. You should use an ORM or some other persistence mechanism in order to abstract application logic from the implementation of your persistence store. So that it doesn't matter to the software whether you're using MySQL, Postgres, MS SQL database, or whatever you choose. And we have the concept, of course, of environment parity. So, and we'll come to that later when I jump to the second part of the presentation, which basically is done to optimize the time from development to production. Yes, first base of that is no matter where you deploy, you always have the same code base. And developers should be able to control delivery and deployment of their code, at least to the lower environments. And they should also use all this series of tools to create local development environments. Yes, in the beginning, we used to use Vagrant, Ansible, Chef as provisioners. Then now recently, Docker, and particularly the new function of Docker Dev environments, which I invite you to try out in Docker Desktop, has come along. And when we're going to the cloud anyways, Terraform and other infrastructure as code solutions will allow us to create and tear down development or lower environments and treat them as a commodity. What does that mean? We no longer need permanently provisioned server for testing, for integration, or for load testing. Yes, we can create them and destroy them at will. What else? A herd acting as a herd. Okay, imagine that we have many cattle doing exactly the same thing, or many sheep doing exactly the same thing. But sometimes we need them to act in a coordinated way. Okay, this is something that is related to persistence, but still is slightly different than that. Why? In the stateless context of a container or of a microservice, we should only keep the data that is individual and strictly necessary for each transaction. But sometimes we need a store for things like sessions and so on. So for that, we should use a key value store or a cache like Couchbase. This is a sort of short-term persistence. Why is it not a good idea to put persistence in container? Well, at least not always. So we were missing a little bit yeah, that we are into data processing. And given the disposable and ephemeral natures of what I've been talking about until now, so instances of our applications, stateless processes, ephemeral environments that we can create and destroy whenever we want, we need to think about our data, which is actually our most valuable resource. Yeah? So we need to show we keep it safe and persistent. And when moving systems into the cloud, it's relatively natural to think, okay, let's put the database there as well. And as I said, it's not always a good idea because, yes, we can attach local and remote storage to containers, to different instances, but it's always a good idea to treat your data, to treat your persistence and storage as what is called, in the next slide, and attached service. With all that, we had Heroku, founded around 2006, and this was the, or 2008, and this was the first easily accessible, so to say, way to deploy code directly into the cloud without taking care of the infrastructure. They use something that's called dynos, and they issued this series of 12 recommendations on how to create an app for Heroku, which is called the 12-factor app. And they have a couple of very good approaches, which we already seen. So one code base, many deploys. You should not need to change anything in your code for the cloud, no matter in which environment you deploy. Yes, it's a very good approach. Yeah, and there's one limitation to this, however, which sometimes is not taken care of. It's, I don't know, who has heard of Conway's law? Okay, can you explain it, please, very briefly, in one sentence? What happens to code according to Conway's law?
Code ends up mimicking the structure of the organization.
Exactly, yeah, that's correct. So where's the problem in today's relatively flat management structures? Okay, there's the problem that there's no guidance. So if you have 10 developers on a team working on the same product, you will probably end with 10 chunks of code structured in different ways. Yeah, it's a bad idea. So basically, try to avoid it, divide and conquer. Keep your modules, keep your individual products as small as possible. Yes, so you can keep the team small and you can keep the different idiosyncrasies and the different opinionated ways of coding and of writing code out of there. And there's another thing you need to take into account, which is that you also need to try and avoid bottlenecks, like at the people approving pull requests and so on. Yeah, this comes if you have read the DevOps handbook, for instance. In there, you'll be able to find a series of good tips on that, because it's following the principles of agile, lean management, applying it to technology. Dependencies, we've seen that with Docker already, so explicitly declare and isolate dependencies, which is what we are able to do thanks to Docker, which I mentioned before. There is one thing we have not seen, and actually the 12-factor app includes configuration in 2 points. It tells us to store configuration in the environment. Okay, this is partly true, but 2 words of warning. Okay, I recommend in short that you use external configuration storage and that you always use external configuration storage. There has been a story in my professional career where we made a very big bet on Kubernetes, and fortunately, it went well. Yes, but we were still keeping all configuration data, and we were also keeping service discovery, to which we'll come later, outside of Kubernetes' own infrastructure. Why? So that if we discovered at some point in time that Kubernetes wasn't for us and wasn't the right solution, we could back out. So try not to lock yourself in technologically with any dependencies. Okay, backing services, we spoke about this earlier. It's persistent. This is the 4th factor, and everything is fine there, and it's just repeating the recommendations and analogies I did. So use abstraction, use an ORM for accessing your database, maintain the code independent from the persistent access, and define backing services in configuration, not in code. And then access other backing services you might need via URLs, APIs, or REST services. And also use queues for asynchronous data, so RabbitMQ or anything that you might want to use. And of course, make sure that your backing services are available. And we'll come to that later in the process model. Now, here's the inconsistency that I have mentioned before in the 12-factor app with code configuration. So they suggest that you join configuration and build into one single release. And I think that's really a bad idea, that configuration should be dynamic and should be loaded at runtime. Okay. Processes, yes? This insists again on the stateless nature of processes, that the process itself should not cache more data than what is needed for the current transaction in the local process memory or in its local file system. And any data that needs to be persisted needs to leave the process and be stored in an appropriate persistence. Port binding. Okay, when Docker started, there was no other choice to expose our service than to expose it via a host port by using host networking. Okay, this has changed because once you grow to a certain scale, this becomes unmanageable. You have to document or at least remember all those ports. So don't use port numbers for this. Use service publishing discovery. Possible solutions, Netflix Eureka, Console, service measures like Istio have this functionality built in. And again, like we did with configuration and with secrets, if you ever need to back out, don't use the platform or orchestration tool specific solutions for this purpose. What else? Concurrency is recommendation number 8 of the 12-factor app. So we scale out via the process model. So different tasks, different type of process. If we need more capacity, we scale vertically, and we create more processing capacity, and we put our web server behind a load balancer or whatever we need, so we can scale. Why can we load balance so well? Because we have nothing that's persistent in each of the processes, so it really doesn't matter where our requests go. Disposability, again, we are treating our software and our processes as cattle, yes, but a couple of good practices. Minimize startup time. It should be really, really quick if one cow dies to put another in. Clearly defined exit shutdown behavior. So make sure there's no dangling transactions left or anything like that. Make it robust. And there's a story I want to tell you about automated health checks and how important they are. And the health check is much more than just testing if our application is alive. That would be a health check of some smoke test of some sort. But testing end-to-end allows us to isolate quickly which animals or which processes are in a bad state and avoid them causing problems. So I had a case where a service would report good health via the Spring Boot health check page. Yeah. But still, we were issuing requests to it, and it wasn't responding. So any idea what could have happened? Okay, yeah, the backend database was down. The application was programmed in a way where it would not catch the database connection error properly. It would appear in the logs, indeed, but the health check page would still report the application as healthy because the health check wasn't end-to-end. So you really need to check each and every single element in order to establish the health of your application. Another look at the environment parity. So, as said, keep development, testing, staging, and production environments as similar as possible. Use infrastructure as code from the very, very beginning if you want to start a journey into the cloud. This is very important. Automation has one big problem, particularly when it's automation of infrastructure as code. Yes, if you don't do it from the beginning, it becomes very hard to implement at a later point in time because it requires you to change the way you work and to change the way you think. Yes, and please do yourselves a favor and implement all your identity and access management, security, network policies, and so on in a lower environment and from the beginning as infrastructure as code as well. Because I've also seen situations where, yeah, it works in development, it works in test, it doesn't work in production. Why not? Because testing and development environments did not have network policies and production did, saying, yeah, we don't need that on test. Logs, as I said, logs are the waste of the animals in our farm. So remember the analogy. It falls through a grid, some other system takes care of it, yeah, running some water through it, like a stream. And what's a stream? A stream means nothing else than our log events are timestamped. Why? This is essential for event correlation and for troubleshooting later on. And we have the dreaded admin processes. So admin tasks should be kept outside of the application process. So you should never build admin functionalities into the application itself. There are some exceptions to that, but nowadays, in order to initialize, for instance, a database, we can use init containers. We can use one-off tasks for hotfixes to data. And the exception, as I said, is in the case of database migration and where you're using a framework or model view controller like Django, Spring Boot, and so on, you should use the built-in functions for database migrations. Now, okay, still any questions? Before that, let me mention that EPAM University program is now starting the second run of our Java mentoring program. The one starting in May is already complete, but there'll be another one in the third quarter. And we will soon have also a cloud and DevOps mentoring program coming forward. So please stay tuned, particularly those of you who would like to get into the world of cloud, of DevOps, and learn about it. Stay tuned, get in touch with us. Don't hesitate following me on Twitter or asking any other of my colleagues directly. And thanks a lot.
Okay.
Okay.
Thanks a lot, Volker.
Welcome. Question time.
Questions from the audience on this presentation? We have one question. Okay.
Yeah. I would say the problem is lack of design from the beginning and lack of many people not grasping the concept that the clouds needs a shift of paradigm from the treating software, servers, networks as pets to treating them like cattle. This is the main shift in thinking that needs to be done when moving into the cloud, in my opinion.
Thank you for your talk. Maybe this won't be a question, but rather a remark to one of the last points, the one about logs and adding timestamps to them. That's very important. But I would also add the need of putting their correlation ID or tracking ID for a particular request to be able to track, to distinguish it and track it from other requests, other processes, etc. And also in case if the request is flowing through different components of our application. So
yeah,
we can...
this is something I haven't mentioned because we could make a specific chapter on APM, application performance monitoring, transaction ID, and transaction monitoring and tracing within Kubernetes cluster or within the cloud. So I made a parenthesis about that. But yes, it's crucial that we also have transaction and tracking IDs in order to establish the correlation, not only on time, but also based on a transaction or on a certain element. So thank you very much for your contribution.
Thank you.
Then one last applause for Volker, and I wish you